talking about Unifying data management in Python with Ibis. But first, who am I? My name is Daniel. I'm a founding engineer at Shore Labs. I'm a software engineer. I like to call myself a software engineer with a knack for machine learning and data analytics. Pretty much I'm a jack of all trades, not much depth in anything. I enjoy sharing knowledge. I used to hang a lot on Stack Overflow back when it was cool, when it was alive. Now ChatGPT kills Stack Overflow. It was already live, but he killed it, definitely. So I'm also an open source contributor. I've contributed, of course, to Ibis, Dask, SRA, pandas, data feature Python binding. They are all data libraries in the spectrum, on the data science, data management spectrum. I was recently elected by lack of opposition to be a Python Barcelona organizer. And a curious fact about me, I lived in Brazil for 5 years, so I'm pretty excited to be here in Portugal for practicing meu português brasileiro com sotaque brasileiro. So, just a quick act here. At SOR, we're trying to define an open expression format that is basically like, let's call it like a intermediate representation for all data frames, pandas, polars, Ibis as well. We call it open expression format. We have created this library that is based on Ibis and Data Fusion. So you can please check it out. Comment, leave stuff, whatever you want to do. So enough with the art, and let's go into the talk. The structure of the talk is going to be, first I'm going to discuss what and why Ibis. I'm going to speak a bit about giving a brief introduction about Ibis, talk about the architecture, how it was built. And then I'm going to give like a 10-minute or less Ibis demo that is based on the 10 minutes tour that they have on their site. Then I will finish wrapping up with a case study of a fictional startup called OnlyMocha, and we can see how the synergies between a data scientist, a data engineer, and a software engineer improve by using Ibis as a lingua franca for data management. So, what is Ibis? Ibis is on their website. They call themselves the Portable Python DataFrame library. Basically, what it means is they provide like a single pandas-like interface for nearly 20 SQL and DataFrame packets. So you can write in Python one expression, and it will execute them either on DuckDB, Postgres, BigQuery, or the backend of your choosing. A key to doing that is lazy evaluation. Ibis first built a query plan and did the first execution to the backend. So here is a plot of the more than 20 backends that Ibis supports. You can see the small one, DataFrame, is polars. They used to support pandas, but they deprecated in the version 10 of the library because the reason was panda is too slow. And for the SQL backends, they use a library called SQL Glob to map the Ibis expressions to the SQL stream that is going to be executed on the backend. So the Ibis architecture, as I was saying, it creates a backend agnostic query plan, no data loaded, not anything. Some data because they try to provide a schema validation for better interaction with the data. When you execute, you call one of their eager execution methods that is two pandas, two polars, or .execute. It compiles your expression and it sends it to run in the native SQL backend. The backend by default is DuckDB because they have found that is currently the in-process or embedded backend, SQL backend for analytics. And but you can easily swap into Postgres just by changing the connection. We will see that later. Yeah, as I said, you can switch it, you can simply, what this backend swapping enables is you can seamlessly change or switch between environments from testing, from staging, production, etc. And if you need to explicitly run your SQL, Ibis has this function to SQL, so you can generate the queries and run it without no Python at all. So quick demo here. So basically, like all libraries, you start by importing Ibis. You create like a connection. The connection is going to be your main entry point to handling all your tables or your metadata about those tables. In here, we are connecting to a DuckDB database that has the penguins dataset. And we are querying the table. As you can see in the output, here the only output that you have is the name of the table together with the schema. The schema is basically the name of the columns and the data type of the column. You can also list tables, and you can also do things like con.read CSV. I'm doing this. This was not planned, huh? So if it fails, it's not my fault. So in here, we're just saying to the connection object that reads a CSV that is supposedly located on that address, on that path there. Yeah, here we have it. Since we didn't provide a name for the table, Ibis created a name for itself. As you can see, it's Ibis res plus a hash. That is just, not a hash, it's just a random string. We can continue with our exploration of the data. In here you have we are going to perform a head operation that just returns the first few rows from the penguins table, and it converts it to a pandas data frame. Here is the output. If you only use the operation, the head operation, it will output like the query plan that is going to be executed. And here you can see that R0 is the database table penguins, that is the source of our data. And then you're performing a limit on R0. And one of the arguments of that limit operation is n equals 5. That means just fetch the first 5 rows. If you want to get immediate interaction from Ibis, so basically execute the query each time you perform an operation, you can set the Ibis options interactive to true, and then basically you say penguins head, and then you have it. They have their own format for showing data. This is the penguins data. Together you have the name of the columns, the types, and the rest of the operation. So some common operations that Ibis can do, it can filter the data. In here we are only fetching the penguins that has Adelie as the species. You can, of course, combine those filters with an AND or operation. You can do select. In here we are using the select to only passing strings as column names. But you can also call, kind of like you do in pandas,
you can call penguin dot the name of the column, and it will also work. And of course, you can mix them together. For transforming data, Ibis, or specifically columns, Ibis has this mutate, kind of like the pandas assign. When in here we are transforming the build length that is in millimeters to centimeters just by dividing by 10, and we are creating a new column called continent that is going to be the same value for all those, for all the rows, and it's going to be Antarctica. And you can change operations together. Basically, just create the new column and select that new column. You can see the name here, bit length in centimeters. One of the most powerful, or not most powerful, but curious Ibis features is their selectors that they have. So in here we have been selecting columns by name. You can also specify other tables, other types of selection. In here, for example, we are mutating, we are creating the build length centimeter column, and we are selecting all columns that are not the build length in millimeters. This selector is saying S, select all columns that matches build length, and then we are putting a knot on the front. So, well, it would match every column that is not the build length in millimeters. Another interesting selector that we could use is in here we are selecting the island, but we are selecting all the columns that are numeric. Other operations that Ibis has, order by, you can pass the column to order by and select. If you want to select in descending order, you just do Ibis desk on the column name, and it works. A more interesting operation is aggregates. You can call the name of the column and min, max, first, last, whatever aggregate you want to do. You can combine multiple ones. You can do also group by, but by itself it doesn't do much. It will only return the keys of the group by. But you can group by multiple columns, and you can use the aggregate on a group by to do operation on a per group basis. And here we are grouping by multiple column, species, and island. And we are also doing multiple aggregations, min and max. So if this is a more complex example that where we are chaining it all together. If you have the question, for example, what was the largest female penguin by body mass on each of the islands in the year 2008? Basically, you do a filter on the year 2008, female on the sex, do a group by island and an aggregation of the body mass, and then you have here the answer. Similarly, you can ask, what about the largest male penguin by body mass on each island for each year on data collection? And so you can do filter by sex, male, group by island year, aggregate by body mass. In here you see that we are renaming the column. We are going to call it max body mass, and then we are ordering by the name of that new column. So here is just to get your appetite wet with Ibis. Now to the use case, Only Mocha is a fictional coffee marketplace with lots of data. There's only 3 people in the team. Anna, that is a data scientist, mainly doing exploratory analysis in pandas. João, that is a data engineer, that he's used to doing production data pipelines in SQL, and now he's cool and he's using DBT. Maria, software engineer, that is writing backend APIs in Fast API, but it could be Flask, Django, your framework of choice. So, what is the challenge? They are having a brainstorming and they're deciding on which technology they want to use. And they have heard of Ibis and they are contrasting whether to use Ibis or not. So if they don't use Ibis, for example, each one of them writes on their own technology, it means pandas analysis has to be recoded by your own in SQL for Postgres, or Snowflake, whatever Joao was using that day. Joao SQL needs to be rewritten or re-implemented by Maria in Python. Or moreover, if Anna has something interesting that she did, it wouldn't be useful for Maria because Maria doesn't know any pandas. Of course, this kind of duplication introduce bugs, introduce delays. There is no understanding on what is done by the data scientist, by the software engineer, and of course that miscommunications always bring problems. So if they use Ibis locally, they have this common understanding between all the roles in the company of what is happening, and they probably could use some code. For example, now I'm going to, let's see, one of the first tasks that every data scientist has to do is cleaning the data. So Anna wrote this. Is the code, you see the code well there? Yeah, cool. So Anna is reading, is using Ibis to read the CSV, the coffee CSV that has all the data, roster country, roster name, price, SCA points. SCA points is like a points that an international organization gives to the origin of the coffees. And she has to clean the roster name. It has some extra white spaces, the roster country, the title. The altitude has also some extra weird characters that are not numbers, digits, and he is stripping those, converting all to Opera and replacing all non-numeric characters by the blank space or the empty space, and casting that column to int64. SCA points, there are some that are null, so she's filling with 82, that not too high, not too low. Also the coffee price in euros per 250 grams is setting at 18. And also stripping some extra white spaces on the description. Finally, it's filtering by not null on the roster country, the origin country, and the price in euros. She is planning on writing to this data to Parquet. It's as easy as doing this. Perfect. But now, if she was using pandas, Joao will have to rewrite all of this when trying to import the data from the coffee CSV to their own production database. But now with Ibis, you have to do Ibis to SQL expert. You select the dialect you want it to be written to. In this case, it's Postgres. It's called Clean Coffee. We printed. And you can see that it will generate the whole SQL query on the flight. You can also choose another dialect, Snowflake. So with Ibis, you are not only getting faster because DuckDB is faster than pandas, and DuckDB is the default backend in Ibis, so the ANA's analysis are faster. But you are also getting this extra information that is the SQL query that can be used later by other roles in the company. Another task that ANA has, they want to see some sort of plot about coffees, the price of the SCCA points and the price in euros by region. One thing that I have to mention that Ibis has integrations with many plotting libraries like Alter, but if there is no ready integration, you can always convert to pandas and use that. That is the case that we're using here with Plotly. And if we run this, so in here what is interesting is this. You have the coffees filter, and you're filtering the coffees by this region. And this same filter can be later used when defining an endpoint in the Fast API, Race API for listing coffees, as we will see. Let me show you really quick this just a normal CSA versus price, and you can filter out by remove some regions that you don't want to analyze. Last, one of the things that Anna does is she builds a recommendation system that is really simple. It has a relevance and a similarity, and the similarity between the two coffees is based on the tasting score. That is basically if the tasting node overlap, the length of the overlap, and if they have the same region, it adds 1, and if they have the same country, it adds 1 more point as well, and it calls score. And the relevance is basically a linear combination of the SCA points and the price by euros. She does his data processing, basically calls similarity by this region, and we can see the similarities for this one coffee in particular, the score and the relevance. But what is interesting about this is not this formula or this analysis, is that if we go here, I have a small Fast API app, and in here, once they have the data in the same format, you can see that Maria is using the same similarity function that Anna defined and the same relevance. No rewriting, is all the same language. So yeah. Before moving to the key takeaways, I'm going to speak a bit about Ibis versus SQL, when to use SQL. When you really want to optimize a SQL query, Ibis will not help you there. So you probably rely on using manual optimization or using a specific query optimizer, or in highly secure and regulated environments where the data cannot leave the database, is also useful to use SQL. When to use Ibis when you need to switch between different data engines, working with both SQL databases and DataFrame-like systems. So the key takeaways is Ibis provides you with faster iteration loop. It gives you code reuse, as we saw with the example between Anna and Maria's. You can use SQL when you need, also provided by Ibis to SQL. It provides environment management. You can easily, I have here in the code is basically a mock function, but you can have like a function that given an environment variable, you can change the database you are connecting to, and the code would work. This is useful for testing, staging, and deploying to production. Yeah, in general, fewer bugs, easier maintenance. That's it. Thank you. You can find all the code on the GitHub link. Any questions?
I'll pass you the mic so the live stream can hear it.
Yeah, hello. Yeah, my question, the difference between much popular pandas, I believe, is that pandas does everything in place in memory, and Ibis transforms the data using some SQL-like engine or other backend. Is it the main difference between pandas?
Yes, pandas doesn't have it does everything in memory, and it's eager in the evaluation. When you call a pandas method, it will actually execute that method. Ibis doesn't. Ibis builds, let's call it like a query plan, and then when you call execute, it executes that query plan, as you said, against the backend. This gives the opportunity for the backend to optimize the query that it's receiving. But yeah, other than that's the main. The main difference is pandas is eager and in memory. Ibis is deferred or delayed. It doesn't have to be in memory. It can be even remotely. You can be doing queries against a remote PostgreSQL database using Ibis.
Thank you.
Well, it looks like it's a promising library. Just out of curiosity, does it support transactions? If yes, do you manage the granularities, the different granularities for different databases?
I don't think, I'm not sure, but I don't think it supports transactions because not all, for example, it writes codes to polars, and I don't think polar support transaction because that's a database concept. It's only to doing queries to query your database with Ibis. It's not, and perhaps that's a con of using Ibis. It's not supported to replace it's not meant to replace your ORM or any of those nature. It's just to query. When you have to query your data, Ibis is a good option. When you have to do more complex stuff like, I don't know, what is they called? User-defined processors or user-defined stuff, it can be cumbersome.
Thank you for your talk and for all the questions. Thank you again for the talk.